So as you can see on the board there, we are looking at the success criteria for today being that I can factorize non-monic quadratics, which is very exciting. I'll explain what that means in a second. Sorry, technology fail again. There we go. And secondly, I can factorize a variety of expressions. So basically, what we've been doing up until now is we have been like, here are some difference of two squares to factorize. Here are some perfect squares. So the last here is what we're going to do is non-monic quadratics. Don't worry, I'll explain what that means. And then I just want you to be able to practice, like, given any old expression, choose the right kind of approach to it. Oh, is this a difference of two squares? Is this a perfect square? Blah, 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 blah. So that's where I'm headed. But to start us off, though, we're just looking at non-monic quadratics. Now, first of all, non-monic. So, well, first of all, quadratic, really. Who's heard the phrase quadratic before? Just raise your hand. I'm not going to ask you to define it. Okay, great. So quadratics, for those of you that didn't have your hands up, are any expression which have an x squared in them. Okay, so this is just using this as my scratch space for the time being. I'm going to rub it out in a second. That's basically all it is. So what we say is that a quadratic is any expression of the form ax squared plus bx plus c. That's what makes a quadratic, where a, b, and c are just numbers. Is that okay so far? So question, this is not to do with non-monics here, but just as a side question, is 16 minus x squared a quadratic? Is it? Is it? Yes, it is. It is. It's a quadratic. Because if I wanted to, I could write it as negative x squared plus 0x plus 16. So a is -1, b is 0, and c is 16. So it is a quadratic, even though it's not a, in inverted commas, normal looking quadratic, 16 minus x squared. So effectively, the only thing you really need is a squared x in there somewhere. Now, the other thing I just wanted to point out was that a, therefore, for it to be a quadratic, a must not be equal to, b and c can be, but a must not be equal to, yep, 0. Thanks for whoever called that out. Okay, because if a was 0, then it'd be 0 times x squared, which would make it linear, right? bx plus c if a was 0. So a can't be equal to 0. Up until now, when I've asked you to factorize a trinomial or a quadratic, it's been a monic quadratic, which means that this value here is 1. Oops, I meant to write monic. Okay, so a non-monic quadratic is one where a is greater than, well, I don't even say greater than, is not equal to 1. There we go, non-monic. Nope. Okay, so I just wanted to write this down just so you've got a general feel for it, and then I'm just going to write some proper theory notes down for you. But does that make sense so far? So that's all it means. I'm just trying to give you the language behind it. So if I say factorize a non-monic quadratic, I'm saying a quadratic where the x squared bit has a value in front of it, like 2 or 3 or 4 or 5. It's not just 1x squared. Okay, all right, let's write some notes down about that then. So this is for your summary book now. I did warn you, this was just scratch space I was using before. Right, so factorizing non-monic quadratics. A quadratic has the form ax squared plus bx plus c, where a does not equal 0. B and c can be anything you want it to be. B and C can just dream the dream. They can live and be whatever they want to be, but poor old A cannot be a 0. Okay, and I've explained why. A non-monic quadratic is when A does not equal 1. Now, what I'm not going to deal with, because it's just a pain in the butt, but there are ways you can deal with them, but I'm not going to deal with A being a fraction. So I'm just going to stick with A being a full number, a whole number. So e.g., 4x squared plus 15x plus 16. That's a non-monic quadratic. Okay, any questions so far? Now, I'm going to go through an explanation about how to solve a non-monic quadratic like the one just up there. And I think I'm just going to do it by example, because I think if I just try to explain it a little any more abstractly, then I think I'm just going to lose you guys. So I'm just going to go straight for the example. But I wanted to explain why we need to pay careful attention to non-monics. And I'm going to start. This is not for your notes, so don't write this into your summary book yet. If I had x squared plus 15x plus 16, that's pretty straightforward to solve. You might not, sorry, I might make it the other way around. That's now pretty straightforward to solve. X squared plus 16x plus 15. Okay, it's easy enough to solve because you can either use the box method or you can use the cross method, or you can use some other method to solve that relatively simple, or even just by inspection and intuition. So you're basically saying, what two numbers can I multiply together to give me 15 that will give me, when added together, 16? It's 15 and 1, right? 15 times 1 is 15. 15 plus 1 is 16. And so we can go, that's equal to x plus 15 times x plus 1, and you're done. No, I didn't even use the box method there. Now, you could have used the box method and got there yourself. I don't think it's a terribly difficult one to do, though, really. The only thing that might make it difficult is lack of practice. When we add a 4 in front of it, it makes a massive difference because we can't use the same logic by itself. The 4 adds into it. If I just treat it like as it is there, then if I expanded this, I would get x times x equals x squared, but I need 4x squared, so that's not going to work. And if I just say, well, I'll just stick the 4 out here, that's not going to work either, because then, yeah, sure, I'll get x squared plus 16x plus 15 on the inside, but with this 4 outside, when I distribute the 4 here, I'll get 4x squared, but then I'll get the numbers here won't work. So I can't just get rid of the 4 in some magical way. Now, what would be nice is if I could just get my eraser out and just erase that 4, but that's not going to work either. So we need to have a slightly more creative way of solving it. It's not that creative, actually. We do need to use the box method. A cross method would also work, but we need to be really careful about what we're considering for our factors. I'll show you what I mean. First of all, I'm going to draw my box up nice and big, and you'll see why in a second. That was a bit too big. I need room. So I'll draw my box up like so. And again, I identify these two corners here as being the first and last term. So in the top corner, I put my squared term in, and in the bottom corner, I put my 15 in. Now, what we know is that we need to find two numbers that will multiply together to give me 4x squared. So that times that equals that. And we need to find two numbers that will multiply together to give me 15. And we know that when I add these diagonals together, I need to get 16x. That's straight factorization kind of logic. Where it becomes different from other problems is that the 4x squared changes the kind of combinations I can consider. And that's where it gets a little bit tricky. Now, first of all, just up on the top, I might actually zoom up now if that's okay. If you've read those other slides, you should be okay with that. Up in the corner here, I know that I've got some factors of 15 I can consider. I've got 15 and 1, and I've got 5 and 3. But when it comes to non-monic quadratics, the order is important as well, and you'll see why in a second. But I also need to consider 1 and 15, and I also need to consider 3 and 5. So the same pair, but reversed, and we'll see why in a sec. And the other thing we need to consider, which I'm going to just write down, then erase, and I'll tell you why as well, is it could also be negative 15 and negative 1, or negative 1 and negative 15, or negative 3 and negative 5, or negative 5 and negative 3. All of these will multiply together to give me 15. So there's quite a few different combinations when you have to consider that the order is important as well. I don't have to really consider the negatives though. Why not? So raise your hand if you can tell me why I don't really need to consider the negatives. Max? Especially? Yeah, especially the middle term. Yeah. Max? It's a good question, Max. I'm just going to stop you there because I'm going to show you why it does matter. In a monic quadratic, where I've just got x squared plus blah blah plus 16x plus 15, it does matter. Yeah, it does. I think you may be jumping the gun, Max. So can I just stick a pin on it? And if there are people in this room that can very intuitively see what the factorization is, very well done. But let me step through the process anyway, because I think the process is actually more important than being able to jump straight to the right answer in a sense. And kind of to answer your question, Max, a little bit further, I'm actually going to deliberately choose the wrong first pair to start with. So you can sort of see the process in its entirety. So I'm going to zoom up on this box. I need to have two numbers that will multiply together to give me 4x squared. So an example of that would be 4x and x. 4x times x equals 4x squared. That's one possibility. There are more. Now that I've got that out of the way, I now need to consider pairs of numbers that will multiply together to give me 15. So an example of that would be 15 and 1. Now let me look at the cross multiplication here. 15 times 4x is equal to 60x. X times 1 is x, and that gives me 61x. Now, 61x is close to 16x in that the digits are the same, but apart from that, they're very different numbers. So these two will not add together to give me to the middle one. So these cannot be the solution. Now, this is what I was trying to say next, is that we do need to consider the reverse. So 1 and 15 here. Now, x times 15 will give me 15x. 1 times 4 gives me 4x, and 15 and 4 gives me 19x. So it didn't give me 61 like before, it gave me 19. And 19 is very close to 16 as well if you flip the 6 around on its head, and then it will be 19. But again, that's not mathematically sound way of solving things. So that is not a likely pair as well. So does that kind of answer what you were saying before, Max, that order does matter? I know that you might have been stepping one or two more steps further ahead. But in terms of if we don't know which pair of numbers to use here, then where we put the 1 and the 15 does matter. Awesome. Okay, I'll have a look at your method, but I would suspect that any method you choose, order would matter. Yeah. Okay, so we've run out of options with 1 and 15. That doesn't work. So we need to move to the next factor pair, which is 3 and 5. So I put 3 here, and I put 5 here, and I go again. 4x times 3x is 12x. 5 times x is 5x. We've got 5x plus 12x equals 17x. And unfortunately, mathematics is so precise that we can't say, close enough and be done with it. Okay, so we've got to say, no, that doesn't match up. Time to move on. So we cross these out and we flip them to see what we get there. So we've got a 3 here, we've got a 5 here, and we go again. So 5 times 4 is 20x, and x times 3 is 3x. So now we've got 3 plus 20 is 23x, still not 16x. So we've tried all possible pairs with in this box here, and we haven't got the right solution. Sorry, do you need clarification? Okay, then you're focusing. So next thing, we need to, I'm going to have to zoom out so you can see this next to each other. We need to draw the box again and attempt the same situation, but consider new pairs here. So in this case, I'm going to go 2x and 2x will give me my 4x squared. And now I need to consider pairs of numbers that will multiply together to give me 15, that will cross to give me 16x. Okay, so we're repeating the process again, but we're using a different starting pair of values for the x squared term. Okay, now if I choose 15 and 1 again, I can see I'm not going to get the right answer, am I? So I'm just doing it for the sake of completeness, really. 15 times 2 is 30x, 2 times 1 is 2x, and 30 plus 2 is not 16. It's double it, but it's not it. So that doesn't work out. Now, in this case, I don't need to flip the 15 and the 1 because I've chosen 2x and 2x. So because 2x and 2x are the same value here and here, there's no point flipping. Okay, here I have to flip them because the 4x and x are different. But because it's 2x and 2x, no point in flipping. Okay, so 15 and 1 didn't work. Cross, 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 cross. So now I'll try the other pair, which is 3 and 5. Oops, wrong spot for that one. So here we go again. 3 times 2x is 6x. 2 times 5 is 10x. 10x plus 6x. Oh, thank goodness, it's 16x. We're there. So we finally found a pair of values in those other diagonals, which will add up to give me 16x. And so I can conclude that 4x squared plus 16x plus 15 is equal to 2x plus 3 times 2x plus 5. 2x plus 3 and 2x plus 5, just reading across and down ways. And we're done. Now, I deliberately took probably the most slowest route possible to solve it, and I did that deliberately. The reason why I did it is because I think what I have noticed in my other class is where people get stuck is where they freeze at the start. They look at a problem like this, they draw the box up, and they go, oh, I don't know where to start. I don't know what to do. And when I unpack it for them, it's clear that what they're not sure is what the final solution should look like. Should it be 2x plus something times 2x plus? They're not sure. And the answer to that is it doesn't matter, right? You start somewhere. You know that you can fill in this box because it's the first term. And you know you can fill in this box because it's the last term or the term without the x's in it. And I know that you can work out factors of 4x squared, and I know you can work out factors of 15. So you've got all the tools. It's just a matter of then trying different combinations until it works. And of course, if you run out of combinations, then you know it'll never work. But it's just a matter of trial and error until you get it. Now, with time and expertise, what you'll find is that you are more likely to pick the right factors to start with. So you might go, like, to be perfectly honest, I mean, I've now done this problem for 3 different classes, so I was pretty confident I knew what the solution was going to be because I'd done it so often, this particular problem. But if I got this problem cold, I wouldn't quite know whether it was going to be a 4x plus something times 1x plus something or a 2x times a 2x like the actual solution was. I wouldn't be quite sure. But it would be pretty clear after I started the box method that I just wasn't getting anywhere with 4x with the 4x and times x, and so I'd move on to the next box and try that. But the important thing is it's okay to just start somewhere, and then after you've had some experience, you'll find that the somewhere that you start is probably more likely to give you the solution. You know, you're sort of making more intelligent decisions as you go along, or not. I won't even say intelligent. That's a dumb word to use. A more experienced decision earlier on. So just start, okay? Right, so I'm going to stop there for a moment. The next thing I'm going to do is I'm going to write up some questions for you to do from your textbook. and then you'll have time to complete those in class. I'm also going to run back to class and get some puzzle sheets for those that finish the textbook work, or for people who want a break from the textbook work. But every single student needs to start the textbook work first and at least do a few problems from the textbook before moving on to the puzzle sheets. So before I put that exercise up, I'd like to ask if anyone has any questions about any of these 4 slides here before I move on.
Is there just an easier way to factorize non-monic quadratic without the box method?
Yeah, there's a method called the cross method, but ultimately, as you can see, this is a long way, but it is nevertheless, it's not too hard. It's just long. So is there a faster way of doing it? Not really. It just requires experience to know which factors are more likely. Good question. So there seems to be a bit of chatter. So that means there are either questions or you're over listening to me. So maybe if you're over listening to me, pop your head on your desk and have a little rest while I take people who want to ask questions and respect their right to ask the questions, please.
With the monic ones,
Yep.
you do the factors of 15 that add up to 16.
Yeah.
Can't you just do the 4 number times 15, which is 60, and then 10 times 7, which is 16? Yeah.
You can do something like that. Yeah, there is something similar that you can do by multiplying those 2 things together. That's true. I'd forgotten about that method, to be honest. But to me, that one really spells out what you're doing, I think, whereas the other one's a bit mathematical, but yeah, you can, technically. Anything else? Oakley doke, yep.
Would there ever be a time where like the 4x and the x could also work? So like because that 4x by x didn't work with them,
Yeah.
would there ever be a time where they both work? Or
not really? Not really, because otherwise they'd be completely different expressions.
Yeah.
Like, yeah. The only time I could think that maybe there might be a bit of overlap is if they were all even and there was a common factor of 2, but you should take that out first. Yeah. That kind of thing. Good question. Anything else? Okay, if you've got questions that you think you want answered and you're a bit too shy to say in class, just say. I'm going to have to leave that screen so that you can see what work you need to do. So here it goes. We'll look. I don't have the page number down. Sorry. It is exercise 8G. And I want you to do just the right-hand side. So don't do every single one. And I'm going to give you 3 jump-in points. If you're unsure, start off with question 3 and then move forwards. If you're okay, just start at question 4 and move forwards. And if you're solid on it, so ITB, then you can do question 5 and move forward. And then, like I said, after you've at least done a few problems, I'm going to give you some puzzle sheets. And the puzzle sheets, I don't have enough one for every person, but I've got enough so that if you wanted to just have some practice with miscellaneous problems, they'll be there for you. Okay, get stuck into it.